with exactly, where you can really use it.
Doctor,
Yes.
in the project when we do a class diagram, you said we just comment on what we do. What do you mean by that?
Right, can you say it again, please?
In the class diagram,
In
in
the
the
phase
project.
two.
Yeah, yeah. You
Yes.
said do a detailed class diagram and comment on everything good. يعني, everything we do, should we say it? Like
Correct.
if we want to group this, we should. That's what you want.
Yes, okay, okay. Now, what we really want is, if you guys, I'm pretty sure all of you guys realize that in the first phase, when you guys looked at the existing SRS documents class diagram or a domain model, it has so many issues and it was very complicated and ill-organized, right? Now, in this phase, I'm expecting that you guys will go on and now you know the design principles, you know the package principles, you know some design patterns even now, right? So I'm expecting that you apply these concepts on that system. And basically, I don't just want a diagram there because it will be almost impossible for me to judge that what are the things, what are the rules you applied and where you applied, right? Because just looking at the diagram, it will be very hard. So in addition to making that diagram, it's up. I'm leaving it to the groups. Some groups use color codes, right? They say that these green classes are using a certain design pattern, and we applied a LEC substitution principle on this set of part of the code, something like this, right? So this is what I mean by give me the details. Is that you somehow let me know which principles you applied, where you applied in the diagram.
Great. The diagram and the principle that we
Yes,
use.
they're the
Okay.
principles we use. So
Okay.
so that I can actually understand, by looking at your diagram, that how you guys, achieve this diagram and exactly what you guys did.
Great. Thank you.
Great, good. Thank you. Thank you for the question. Probably it will help everyone, inshallah. Okay, guys. So shall we start? Any other question before we start?
Let's get going.
Oh, let's go going. Yes. Bismillah. I hope you guys can see my screen, right?
Yes, Dr.
Yes,
Wissam.
it's visible.
Okay. Thank you. Okay, Bismillah ar-Rahman ar-Rahim. So we have these design patterns. We have been talking about this for maybe 2 to 3 lectures. And remember, the whole idea behind design pattern is that you have certain design issues or certain design properties you want to achieve, and industry practitioners and researchers over the years have identified that certain properties can be achieved that if you organize your system or you use certain way of creating your objects and so on and so forth. So we have design patterns. There are 3 categories of them. We looked at the first category, which is your creational design pattern. And this creational design pattern basically allows you to create objects. And we had examples of singleton, factory, abstract factory, proxy, and the builder. Today, we're going to look at another dimension or category of design patterns, which is called the structural design pattern. Now, the structural design pattern, as the name says, is all about how we can better organize your structure of the application. And then again, there are quite few of them, as was the case with creational. I'm going to pick few which I believe are quite popular and are really beneficial for us to understand at this stage. So as I said, structural design pattern is all about ease for us to identify or basically organize your classes in such a way that it's very easy for you to simplify and realize these relationships between entities. So because these classes, these entities in your system are not in isolation. They have method calls, they have associations, they have compositions and aggregations and inheritances. And of course, you use the abstract class concept and interface classes. So as a result, you have a lot of relationships. And the idea behind structural design patterns is that you want to somehow ease, simplify, or better organize, probably that's the right word, better organize the relationship between entities. And again, there are a range of design patterns which helps us achieve this. The very first design pattern we're going to look at is called facade. Anybody has heard about this one?
I heard about it.
Okay, so what comes to mind?
It's just like if I am a class outside the package, I use facade to limit the access to my components in that package.
Spot on, spot on. Anybody else has used it or saw it? Probably not, right? No, as I said, I mean, Saudi or spot on, you explained it correct, perfectly correct. It is one of the most, probably I'd say it's the simplest one, and yet very, very powerful. And it's really heavily used, and I expect that, you will be using this not only in this project, probably in your 417, 418s, and inshallah in your professional, careers as well, because this is something which is extremely popular, very simple, yet very, very powerful. So basically what happens here is that you want to provide an interface to the package of classes. So you want to somehow, you have a package of classes, you have a subsystem, and you want to give them an opportunity that other classes, other subsystems needs to interact with them. They should interact with this interface or a class. This design pattern basically hides the complexity of the subsystems, and it basically provides an interface to the clients. Of course, by client, we mean other classes which are going to use the classes within the subsystem. So basically, you create an interface, and of course, or a class, or whatever the way you would like to call it, and it allows you to hide the complexities of the system within it, and let the other classes, client classes, access your system via that interface. Now, this design pattern, of course, is structural in nature because it allows you to add an interface to existing system and hides its complexity. Okay, so far so good?
Yes.
Yes.
Yes, Doctor.
So basically it does what? It does basically, it just allows you to create a single class. And that single class will provide simplified methods required by the client classes. This is one thing it will do. And the second, it will also delegate the calls of the methods to the existing subsystems. So again, as a diagram speaks 1,000 words, probably this will clarify what exactly we're trying to say here. Take a moment to have a look and see what's happening here. Yep. So what's happening here without that interface, without that class, without that design pattern? What's happening on this side?
They are connected, but the facade is separate them with one component, which is
Exactly. So basically, in this case, if you don't use this facade design pattern, in other words, you don't create that class, everybody's talking to each other, which is, and a result, at the end of the day, will increase your coupling, right? So a lot of coupling here, right? And as a result, if you have to make a changes here, you need to worry about, who else classes outside the system are talking to it, and they are relying on it. They have kind of dependency on it, and you need to go and test it, and so on and so forth. It's more complicated. Managing these dependencies is very hard, and making changes in them is even harder. You create a facade design pattern. You use a facade design pattern. You create a facade class, and all the classes, which are the client classes, talk only to this class, and it delegates method calls to the subsequent classes within that package, within that subsystem. As I said, this is probably one of the easiest structural design patterns and yet very, very powerful. Are you able to see the benefit here?
Yes, but do you have a code? So understand more.
Of course, inshallah. Here we go. We're gonna, for the time being, we're gonna continue over the same diagram, same example we've been using. So let's see what's happening here. We have the shape, right? The rectangles and the circles and the squares, right? And we have something called, this is our facade class, which is the shape maker. And this is our class, demo class, which is going to be using it. Now, if you look more closely here, you're going to be creating 3 objects, and then you will be, basically via your shape maker, you'll be creating 3 objects. And then you will be able to draw circles, you'll be able to draw rectangles, and you'll be able to draw squares. Now, let me show you the code first, then I'll come back to this slide, and then we'll have a bit of discussion on what exactly is happening here. So, again, this part is very simple. I think we have seen it again and again. Basically, you have the shape interface, and then you have the rectangles, the squares, and the circles going on and implementing the shapes. Now, this is our facade class, the shape maker. And as I said, you will have these private objects of 3 circles, rectangles, and squares. What's happening inside your constructor? You're basically creating an objects of your circles, squares, and rectangles. And then you have these methods which allows you to draw circles, it allows you to draw rectangles, and it allows you to draw squares. And when it comes to the demo class, the class which is outside your subsystem, which is your the demo class, but it goes on and create an object of the shape maker. And as a result, when it creates an object of the shape maker, you create an object of the rectangles, circles, and squares, right? But for the demo class, he doesn't need to know that. For him, at the end of the day, he knows that I need to create a shape maker, and then I'll be able to do on and draw the circles. I'll be able to go on and draw the rectangles, and I'll be able to go on and draw circles and squares. Under the hood, basically what's happening is you create a shape maker. Basically, these objects are created. When you call the draw circle, basically you know that you will go on and call the circle draw. Or in case of rectangle, you draw the rectangle draw. So rather than this demo class calling the circle, calling the rectangle, and calling the square objects directly, creating their objects directly here, and calling these methods directly, what you have done now, you are saying demo class, you need to only be able to talking to our facade class, which is our shape maker. We guarantee you to have these 3 methods class. You go on and use these ones. Under the hood, let us handle it. Is this clear?
Yes.
Yes, they're clear.
Any questions on this? Any ambiguity on this?
Methods, Victor.
Yes, Abdul Majid.
Do I have to make all the methods in the package in the facade class?
All the methods?
Yeah, or just the methods he wanted.
Oh, good one. Okay. Now, this will depend on what kind of, see, if you look at this diagram, it will depend on what kind of functionalities you want to provide from this package, right? Now, if you want to, whatever the functionalities you want to provide needs to be implemented here so that the others can use it.
Okay.
All right. Now the question comes, how I tell the other parts, like in this demo class, how I tell it, what kind of parameters the draw circle will be passing on, or what are the return types and all of that stuff. Because this is just a simple example now. Subhanallah, I think we're week 11, right? So inshallah, in maybe, three to four lectures, we'll be finishing design patterns. Then I'll have one or two lectures on good design. I will have one lecture on good design, then code bad smells. And after that, in probably towards the end of week 12, probably starting with week 13, we'll be talking about something called construction, software construction, right? And in the software construction, I'll talk about this, not only, this is not only for this, design patterns, it's true for everything actually. We're talking about the preconditions, the post conditions, how we specify our methods, how we specify what kind of parameters need to pass on, return back, so on and so forth. So we'll be focusing on that. That is also helpful as part of the design. But we as a class have not yet reached there. Inshallah, I foresee, inshallah, in 2 weeks' time, we'll be getting there. So yeah, in a nutshell, as you said, do I have to implement all of them? Yes, you will have to decide what these functionalities will be provided. And as a result, you need to put them here. But how you specify it, how you write them, how you tell others that what kind of functionality it does, inshallah, we'll cover this very shortly in a couple of weeks' time, towards the end of the semester, about this construction concept. I have a question for you guys. How this is different, if you look at the structure, if you look at the diagram itself, I can easily be confused here, and I can say this is a factory. Shape maker is a factory. Is this true?
It looks like, but not.
Yeah, it looks like, but it's not. How? How it's not? What's the difference? What's the key difference here?
I believe the key difference is that the factory return the object, but the facade doesn't return the
Correct. The aim was different. The objective was different, right? There, the objective was to create circles, rectangles, and square objects. Here, the aim is not that. The aim is to provide the functionalities of these methods to the demo class via one single point. Hence, it has these draw circles, require squares, and rectangle methods here. So we should not be confused about just looking at a layout, basic layout, and say, oh, it's a factory design. But no, you need to look inside it and try to understand what exactly you're doing here. Everybody's comfortable with this?
Doctor, I have a question.
Yeah, go ahead, please.
Can I have more than one facade?
Oh, yes, yes. In a given system?
Yes.
Oh, yeah,
Not in the given system. La, it's like for the shape.
For the shape, okay. No, if I assume here is that you want to provide a certain kind of functionality to this group of classes and you want to provide another separate kind of functionality for some others, right? Probably this is what you're thinking, right?
Yes, it's like complex package, and they have and they think one facade it's not suitable. So I should have two. Am I right?
Fair enough.
Is it okay?
Fair enough. Yes, okay, it's okay.
Okay.
Because this is, as a concept, is all about how you structure it. Everybody's on board with me now. It's not a very difficult one. It's a very easy one probably, but it's very, very powerful one. Any questions on this, guys? Seems to be fine. So, everybody is comfortable what's happening on the demo side?
Yes, Doctor, I think it's clear.
Yes, okay. Thank you, Muhammad. Thank you. Now, just to wrap up this discussion on the facade, the idea is that you want to provide simple interface to a complex subsystem, which is useful for most clients, right? So in principle, you're always looking for an interface to a complex subsystem, and then you want to, make sure that all the clients access through its functionality through that one. Of course, as I said a few minutes ago, it needs a bit more stuff to really work with you need to talk about the preconditions, and you need to talk about the post conditions and how to specify that. Inshallah, we'll be covering this in a couple of weeks time. But at this stage, all you need to know is that you have a simple interface for complex subsystems. Of course, I'm pretty sure all of us have picked this up now. It does what? It helps you reduce the dependencies between the clients and the subsystem, or dependencies between various subsystems. And once you reduce these dependencies, a lot of benefit there, because it's easy for you to maintain, it's easy for you to change, it's easy for you to update, and so on and so forth. And of course, you simplify the dependencies between the layers of the subsystems by making them communicate solely through their facades. In other words, the systems will not be talking to each other, the classes will not be talking to each other, rather they will be solely means only, right? So it will be only communicating through their facades or facade classes. And as a result, you reduce the dependencies. As a result, the clients are shielded, or they don't need to worry about their subsystem components. All they need to know, the client classes, all they need to know is what is the interface, what's the facade, what kind of functionality it provides, what kind of methods it has, what are the parameters I need to pass on to this method, and what are the return types this gives me. And that's all you need to know. And basically, you go through and access them through these facade classes. Of course, as a result, because you're reducing dependencies, we are always very much interested in this. You're going to promote weak coupling between the subsystems and its clients. And of course, we are always interested in high cohesion, low coupling for obvious reasons. And as a result, once you have weak coupling, components in a subsystem can be changed without affecting their clients. You can just go on and change them. You can go on and modify them. You don't really need to worry about, the other parts of the system being affected. As long as your facade has not changed, as long as your interface has not changed to the other client classes. And of course, it helps you promote, porting of the subsystems easier. In other words, because they are all self-contained now, they are very cohesive. You have one single point of entry and exit. As a result, you can reuse your code. As a result, you can make them as commercial off-the-shelf components. So you can, port them in and deploy them easily, so on and so forth. All the benefits of, high cohesion, low coupling achieved through this structural design pattern. In a nutshell, if we have to really summarize this design pattern, the whole idea is to modularize your design by hiding the complexity. I'm pretty sure, and I'm very confident that once you guys now, alhamdulillah, are aware of this design pattern, I expect that you will use it again and again in your careers, in your projects, right? Because this is something which is probably when it will fit in most of the systems from a structural perspective. Okay. And as we had the discussion in the beginning of the class about the project now, the phase 2, once you're going to look at the existing class diagram and you're going to go on and change it, I'm pretty sure most of you guys picked these issues of, a lot of dependencies between them and so on and so forth. Feel free, apply this design pattern, make them more structured. Any question on this before I move on to the next one then? Everybody seems to be confident, right? Okay. Now, in addition to the the facade design pattern, the structural one, we have many others, and the next one we're going to talk about is called decorator. Right now, this decorator design pattern is very, very interesting from a structural perspective. And what it really does, it does what? It allows a user to add new functionalities or also remove new functionalities. Okay, so it allows you to add or / remove functionalities to an existing object without altering its structure. So if you have an existing structure in your system and now you want to go on and add new functionalities and you don't want to change the original structure, the design pattern which allows you to do that is called decorator design pattern. All right. And the decorator design pattern basically, does this. This type of design pattern is a structural in nature because it allows or it acts as a wrapper to existing classes. Everybody is comfortable with the meaning of wrapper here, right?
Yeah.
Right. So it's kind. Yeah, sorry.
Right?
Yes,
Adapter connector, right?
Okay. Now, adapter is a different one, right? Similar but different. I'll talk about adapter, inshallah, probably on Thursday. But the wrapping is sometimes we use we use the same words for the two meanings sometimes loosely. But here wrappers means that you have an existing structure of the application and you don't want to change that, but like a McDonald's wrapper, right? You have on your burgers, for example, right? So it kind of wraps it up, covers it up, and it covers it up structurally by allowing you to add new functionality without altering the structure of the system. And of course, it's structural because this is all about the structure of your system. And this pattern creates, as a result, what really happens here is that you create a class called the decorator class, and which wraps the original classes, and then it provides additional functionality. More important point, and I like your special focus here, add additional functionality while keeping the class method signatures interact. This means while keeping or without altering the structure of the original or existing class. So basically, you don't want to change the existing class, you want to wrap them up. And if this is going to happen, if you're looking for such a thing, the design pattern is called decorator design pattern, and of course, you're going to create a class called decorator class, which will help you wrap these ones. In a nutshell, it allows you to add or remove, objects, in your system. Let's look at this example and see what's happening here. Take a moment to understand what exactly is happening here. Anybody would like to volunteer and help us understand what's happening in this system?
I have a question, Doctor.
Yes, Saud, go ahead, please.
Does the shape decorator is interface or abstract or what? Or the concrete class?
This one, shape decorator,
yes.
Abstract.
Abstract.
Yes.
Okay, and class shape is interface, right?
Shape is interface, yes.
Okay.
Yes, Khalid, go ahead, please.
Yes, Doctor, I have, let's say, initial understand about this draw or this design diagram. The shape here is an interface, or you can say it's about it. general class, and it has subclasses, which is a circle, rectangle, and shape decorator. Also, the shape decorator has another subclass, which is a red shape decorator, which has one more method or function, which is red shape decorator also, and set red border. The decorator pattern demo in the main void, let's say it's about a test of the main class for the shapes.
Correct, Khalid, spot on. So see what's happening here. Let me take it further from what Khalid said. We have this, remember a moment ago what we said about this decorator design pattern? We said what? What is the aim of the decorator design pattern? The aim of this decorator design pattern is to do what? Allow a user to add a new functionality without altering the existing one, correct? So let's say we have this part existing here. So if we have circles and rectangles, we're able to go and draw these circles. Now, the demo class or the client, sometimes he will like to draw a normal circle. And sometimes he is interested in drawing a circle with a red shape, like something like this. All right. So the decorator design pattern itself says that, rather than making changes in your shape and your circles directly, don't do that. If you want to preserve the original structure, the solution is go on and create a wrapper class or a decorator class and implement that new functionality inside it, and let the clients call this decorator shape class to achieve their functionality. So if they're interested in drawing a normal circle, we'll direct it to go and draw the normal circle. If they're interested in getting a red one, we will direct it to go and get the red one. Does this make sense? We haven't looked at the code yet, but does it make sense how the wrapping is taking place?
Could you repeat the wrapper?
Yes. This is the original structure of the system. So we had a shape, and then we have circles and rectangles, and we are able to go and draw them. Now, this demo class, let's assume, was using these ones directly, right? So we can have something like this, directly using it, creating these shapes and drawing them. Now, due to some reason, due to whatever reason, you want to, for example, it's a drawing tool, and you want to give an opportunity here that you want to keep the original structure as it is, but you want to add a new functionality, and that new functionality happens to be the case that you want people to be able to go and draw a red circle or a red border. And this is a new functionality, it's an additional functionality, and you do not want to go and change the structures. And then what you do? You basically go on and create this wrapper. This wrapper is kind of wrapping these part in a sense that the demo class, rather than calling them directly, it will not go on and call them directly. In fact, it will do what? It will basically go through your decorator class now, and then this decorator class will decide, depending on how it's been used or called, that if you want a normal circle, we'll give you a normal circle. If you want looking for a red circle, we'll give you a red circle. So this is a wrapper, which is kind of wrapping this thing, the whole thing up.
Okay, I get it now.
Yes. So now let's look at a bit of code here, and then we'll come back to this one again, inshallah, and then discussion on it. Again, no rocket science here. It's just a simple thing we have been seeing again and again. So basically, we have an interface, and we have a rectangle and a circle, and basically they help us draw rectangles and circles. Now, this is the wrapping part, and I like your special focus here. So basically what we're doing here, we're creating an abstract decorator class which implements the shape interface. First of all, we are doing what? We are making a protected shape. What's happening inside the constructor here?
Taking
It's like
the
I'm
shape.
passing.
Say it again, please.
Taking the shape to decorate.
Yes. And of course, drawing it. Now, let me show you the other one as well, and then hopefully it will become more clear, right? Now, what's happening here? We have a concrete decorator class, happens to be called red one. What's going to happen here in its constructor?
It's like I'm passing a created shape.
So whatever the shape you want to create is actually passing it on, right? What's the meaning of this
Yes.
super? So what's the meaning of this one super? What it will do?
It will use the constructor of the decorated shape.
Right? And it will
Yes.
go on and create an object, right? So basically, and then of course here it has a method called draw, and this draw does what? It goes on, and whatever the object you have created here, the decorated shape, whichever the shape you want, you will go and call its draw method. And of course you have an additional method here which is called set border, which is also part of the draw, a set border, and here you go on and internally it's a private method. You go on and create a red border for it, correct? Now, let's look at the last one. Of course, we'll come back to all of this stuff and we'll have a discussion here. So what is happening from a demo perspective? First of all, it goes on and creates a shape circle, shape object. And why he's doing this? Because if he's interested in creating a normal circle, he will just call circle.draw and the normal circle will be drawn. While if he's interested in a red circle, it will do what? It will call the red shape decorator and pass on a new circle into it. What will happen? This new circle will come here, right?
Yes.
And this new circle will do what? It will go on and call the decorator shape. Super, right? It will go on and create an object of that specific one, right?
Yes. Absolutely.
So exactly. So basically what happened here, we have now one circle. So from a demo perspective, because we have wrapped each thing, and again, the idea behind wrapping is what? We don't want to change the original functionality, rather we want to add a new functionality. So we have an original functionality of having a circle. We create an object of circle. If you want to draw a normal circle, we'll just, alhamdulillah, we'll just go on and draw a new circle, a normal circle. If you're interested in a red circle, you create the red shape decorator to create a new red circle object, and then this red circle will be used to draw a circle with a red border. And similarly, we have a rectangle here as well, so red rectangle can be done here as well. Now,
sorry, Doctor.
yes, please.
In shape decorator, there is no abstract method, or
In the shape decorator, yes. Okay. Now, this is not complete code, right? Of course, but we will have this draw actually, because this draw circle is our draw shape actually.
Okay.
Right. Is the concept clear? Like what's exactly is happening here? Now let's go back. What we did here, let's look at the diagram, because sometimes it's easy to look at the diagram. So what exactly we did? why we are creating these ones.
Could you please repeat the question?
Why we are creating these shape decorators?
I think so. We can like I remember from the close and open principle. So we can violate the close and open principle, I think.
Yes, that will be an additional benefit to it for sure. And you're right, absolutely. Here we are doing this in this structure to support the open and close principle, because tomorrow, if we have a red shaped decorator, if tomorrow down the track, if we want to have a green one, I'll just go on and create a new one, right? That's the real benefit of having this structure here.
Yes.
Which you are absolutely spot on. But let's take it to the next level now. Why I'm creating a shape decorator to begin with? Why can't I just have the red circle here? So let's say, this is the red circle. It was just a, why not I have that red draw here as a method here, and let each of the class implement a red border option here and a red border option here. Why I don't want to do that?
To follow the scope principle, that each class must not contain methods that he doesn't need.
True, true. Now let's take it to the next level now. I say that, the circles are able to be drawn in a normal way, and they are also being able to drawn in a red border. So in this case, it is required, right? So why don't I create a red method, red draw here? Why I'm going through this exercise of creating a shape decorator and taking care of their.
Doctor?
Yes, please.
Maybe because you don't want to violate the open-closed principle.
Let's focus it from the design pattern perspective, right? Of course, the idea is what you want to add. Let's go back. What you want to do, you want to add new functionality to an existing object without altering its structure, right? So for example, in this case, this is one directional, but in a normal system, in a more complex systems, there will be some other classes which might be using these shape interface as well, correct? And
Yes.
they are probably only interested in drawing them. They're not interested in red or a green circles or so and so forth, right? Say for example, this is your drawing tool application. In this drawing tool application, this is like a premium version, for example, where when you purchase a premium version, you're able to draw red circles with a red border and so on and so forth, for example, right? So you have other classes here who are just going to be using a simple drawing method. Now, if you add a red one here, now the problem will come with the Liskov substitution. It will come with all other problems, is that if these classes do not need to have these, reds and green borders, then if you're going to add them here, then they need to worry about this, correct? A and B, the whole idea is you don't want to change the basic structure. In some cases, you don't want to change the basic structure of your system. You want to add additional functionalities here so that tomorrow down the track, if you have to remove it, you can remove it. You want to add one more, you can add it. That this part of the system will not be impacted as well. It's all structured. This part of the application is also not impacted because you're not making any changes to the actual original piece of code. This is the key point for this decorator design pattern. Can I feel comfortable that you got the basic idea behind the decorator design pattern? Of course, floor is open for questions and discussions. If you're not sure, let me know. I try and explain it again.
Do I have a question, please?
Yes, Khalid, go ahead, please.
Is it better to remove red shape decorator and add instead of it color shape decorator so that we can choose any color instead of only red?
Fair enough. Why not? And it's okay. It's okay. It's okay. Absolutely. Though, as long as, if for example, as long as you're saying to me that, and of course this depends on the requirements, Khalid, right? That you have a system in which you have a certain basic functionality. Now, maybe tomorrow down the track in the next version, you're adding a new functionality, right? And you still don't want to change the original one. Then the solution is to do what? Wrap it up. And wrapping it up is basically you go on and decorate it, which means you add another one here. Let the part of the system which need to worry about it handle it. Of course, it could be a circle or sorry, a shape or whatever you like to call it, more generic even, right? And as long as these are not changed and the new ones are added here, you're basically structurally separating them up. You're making things more modular in nature because it's a structural design pattern. It gives you that benefit, and off you go.
All right, thank you.
Any other questions, guys? Can I have some show of hands to give me a bit of confidence about, is the concept clear about the decorator? Thank you very much. I think it's almost 10:50 as well, so I think I'll stop the recording here and take the attendance, and of course the floor is open for any questions. Otherwise, inshallah, I'll see you on Thursday.